Hello everyone. In this session we'll look into another sorting algorithm called as quicksort algorithm. Now this algorithm works on a concept of divide and conquer. Now to understand the meaning of divide and conquer, let us solve this example. The first element is basically what is we said to be a pivot element. Now this element, it can be any element, not required that it should be the first element. Okay, but for simplicity we have taken this first element as a pivot element. Then we will be taking two pointers, one which is pointing to the lower bound. So let us say this is pointer P, and another pointer Q that will be pointing to the upper bound. Now what we'll do over here is we'll find a fixed position of this pivot element. So let us say for a brief we take something like this. We'll find this fixed position where we'll store 20, whatever that index may be. Okay, let us say there are total 8 elements. Let us say this is 5. Okay, at index 5 we are getting the value of 22. Then what are the elements we'll have towards the right hand side? Okay, so those elements will be greater than 22, whereas in the left sub array where the index will be going from 0 to 4, all elements will be less than 22. Now this is what we say it's dividing the array. Okay, it's a division procedure. Conquering, we will look at the end. Okay, so now let us try to solve this. What we have taken over here is first element as a pivot element. Let me erase this so it will be a little bit simpler to understand. Better. So a pivot element is 22, and we are having pointer P pointing to index 1 and Q pointing to index 7. Now P will be moving towards right. That means we will do P plus plus if and only if the element stored at P, that is A of P, if this is less than pivot element. Okay, so now let us see over here what we are having at index 1. We are having 18. 18 is less than 22. Yes, true. So we move ahead. P plus plus. Okay, now we'll take 28. Is 28 less than 22? No. Then P will remain here itself. Then we'll focus on Q. Now Q is towards the rightmost, or nothing but it's at the upper bound. So what we'll do, we'll be moving Q one bit towards left. That means we'll do Q minus minus if and only if element stored at Q is greater than the pivot element. Okay, pivot. Now element stored at Q is 12. Is 12 greater than 22? No. Now neither P can move ahead nor Q can move back. So in this case what we'll do, we will swap the elements stored at A of P and A of Q. Okay, so if we swap this, then our array will consist of 22, 18. So we are swapping elements stored at index 2 and index 7. So at index 2 we will get 12, and rest all elements will remain same. So it's 8, 14, 34, 36, and at 12 we will be getting 28. So this is what we have actually swapped, but the position of pointer P and Q remains the same. So P is at still index 2 and Q is still at index 7, and pivot element is at index 0. Okay, so if I rewrite the indices, so it's index 0, 1, 2, 3, 4, 5, 6 and 7. Now we will continue this process of incrementing P and decrementing Q, and this we will continue so long as P is less than or equal to Q. That means there is no crossover. So now let us continue proceed with this. Now 12 less than 22, yes, so P moves ahead. 8 less than 22, yes, so P moves ahead. 14 less than 22, yes, P moves ahead. 34 less than 22, false. Now P will stay at 5. Now let us focus on Q. 28 greater than 22, yes, so Q moves one step behind. So let me use another color, so that will be better over here. So let us say I use a red color for Q. Okay, so now 28 greater than 22, yes, so Q moves one step behind. That's the question over here. Now Q will become Q minus minus, subject to condition the element which is pointed by Q is greater than the pivot element. So this condition I'm talking about. So now at Q is at 7, not Q as Q is at index 6. At index 6 what we are having, 36. Is 36 greater than 22? Yes, so we move one step back. Okay, that is Q minus minus. Now Q is at index 5. So now is 34 greater than 22? Yes, so now Q moves over here. Now what will happen? There is a crossover. At this instant P is pointing to index 5 and Q is pointing to index 4, so there is a swap. So now at this instance what we'll do, we will divide this array in two sub arrays. Okay, and now before dividing that, what we'll do, we will swap what? We will swap pivot element and element pointed by the upper bound, nothing but the index Q. So index Q is pointing where? Index Q is pointing at 14, that is at 4. So whatever the element at 4 we are having, that will be swapped with the location where we are having pivot element. We are having pivot element at index 0, so this will become 14, and at 14 what we will have, we will have 22. Rest array elements remains unchanged, so this is 18, 12, 0, 8, and towards the right what we are having, 34, 36 and 28, and position of 22 is now fixed. So if we consider this an array with at index 0 we are having 14, at index 1 18, at index 2 12, at index 3 8, then at index 4 that is fixed, and then we are at index 5 34 6 and 7. Now at this instant we are having two arrays, one array towards the left, so which is unsorted, and second array which is towards the right, and this is also unsorted array. Okay, so let me draw this properly. Now this process is what we said to be a divide. What we have done, we have fixed the position of 22, which is the pivot element. Now that index is 4, so we are not going to do anything over here. Then what we'll do, we'll focus on either of the left sub array or right sub array. This is what you can say left sub array, and this is what you can say as your right sub array. So let us say we are focusing on left sub array. We will repeat this procedure. It's a recursive error type. Okay, now here we can take 14 as my pivot element. If I am taking 14 as my pivot element, then P will be pointing at index 1, that is 18, and pointer Q will be pointing to index 3 where we are having 8. So as per the logic, what will happen, P will move to the next if the value is less than the pivot. Now at P what we are having, 18, pivot element is 14. Is 18 less than 14? No, so this will remain as it is. Now we'll focus on Q. At Q what we are having, 8. Is 8 greater than 14? No. So this condition of P plus plus and Q minus minus, it holds again. So what we'll do, we'll swap the elements at index P and index Q. So what we'll get over here is 14 is the pivot element, and over here what we'll have 8, and at position 3 we'll have 18, and index 2 it remains the same. So I'm rewriting this index 1 0 1 2. 14 is my pivot element. P is pointing at index 1, Q is pointing at index 2. Then now 8 less than 14, true, so P plus plus. 12 less than 14, true, so P plus plus. Now let us focus on Q. Q is at value where Q is pointing is 18. 18 greater than 14, yes, so swap it. So now Q comes at index 2 and P comes at index 3. So this should be 3 over here. Okay, so there is a swap. Okay, now what we'll do, we will swap, or there is a what we say crossover between pointer P and pointer Q. Q is pointing at index 2. So what we'll do, we will swap pivot element and A of Q. So at A of Q, that is index 2, we are having 12. So 12 will be at index 0. At index 1 we are having 8, and at index 2 what will have our pivot element, that is 14. Okay, and at index 3 what we are having 18. Okay, now again we are having two subarrays. One towards the left subarray there are only two elements, those are nothing but 12 and 18, whereas towards the right, not 12 and 8, 12 and 8, whereas towards the right there is only one element, that is 18. So if we consider that subarray, then it being a single number, it is already sorted. So if you consider okay, let me proceed this, let me rewrite over here. So if we consider the right subarray, then right subarray is already sorted. So here we can say 18 being a single element, it is fixed. So at index 2 you are having 14, and at index 3 you are having 18. Now we'll focus on the left subarray. Left subarray consists of 12 and 8. So let me say the first element is my pivot element, that is at index 0. Okay, now this is my pivot. P and Q will both point at 8. Okay, so 8 less than 12, yes, so we move ahead. There is nothing but there is a plus plus. Okay, if you move ahead there will be what we say to be a crossover. So what we'll do, we'll simply swap A of Q and pivot element. Right now there are only two elements, so we get 8 and we get 12. 12 as index 1, and being 8 at the only element, so this element is also sorted. So if you look into this, into the array, we have element fixed at index 0 1 2 3 and index 4. At index 4 what we are having, 22. Okay, then we focus on right subarray. Right subarray consists of 36 34 36 and 28. So now here let us say pivot element is 34. Let this be the pivot element. My P is pointing at index 6 and Q is pointing at index 8. Now 36, is 36 less than pivot? No, so it will remain as it is. Q, that is 28, is 28 greater than 34? No. Then what will we do? We will swap A of P and A of Q. So if we swap A of P and A of Q, we will get 34. We'll get 34, 28 and 36. Now P is at index 6, here is P and here is Q, and pivot element is 34. Now we'll check a look into this. 28 less than 34, true, so P moves ahead. 36 greater than 28, not 28, 36 greater than 34, yes, so Q moves over here. So what we get, there is a crossover between P and Q. So we will swap pivot element with A of Q. A of q is at index 6, that means this position. So what we get over here, position of pivot element is over here. Towards the left you are having only one element, that is 28, and towards right also we are having one element, that is 36. As there are only single elements, what we can say is both the arrays, both sub arrays are sorted. So this is 28 and this is 36. So if we look into the position over here, at index 5 we are having 28, at index 6 we are having 34, and at index 7 we are having 37. So total 8 elements. So now we'll reconstruct the array considering the positional value. So this is nothing but what we said to be conquering. So let us draw the array first. Okay, so at index 0, index 1, index 2, index 3, index 4, index 5, now this will be index 6, and last this is nothing but index 7. So at index 6 what we have got is 8, at index 1 you are having 12, at index 2 you are having 14, at index 3 you are having 18, at index 4 what you got, the very first element, that is 22, at index 5 you are having 28, index 6 you are having 34, and index 7 you are having 36. Now this is how basically this algorithm works. It's a recursive algorithm. Every time you need to find the position, a fixed position of the pivot element, and then you are dividing your array into subarrays such that whatever the elements you will have in left subarray, those elements will be less than the pivot element, whereas whatever the elements you will have in your right subarray, those elements will be greater than the pivot element. So this is how basically your quicksort algorithm works. As far as your usage is concerned, depending on time and space complexity, it is little bit different. So if you consider the best case, okay, so when you are considering the time complexity, we consider 3 cases. First case is what we said to be the best case. Second case we said to be a average case, and third is what we said to be the worst case. Now best case, it happens whenever what we can say that whenever the pivot element we are taking it, okay, this pivot element is basically is at the central or middle of the list. In that case, the best case or the time complexity is considered as or obtained as big O of n log n, and same obtains for your average case. Average case in the sense, what are the elements you are taking, those elements are not properly arranged. That means neither those elements are coming in ascending order nor in descending order. Okay, so whatever we have taken right now, the first the example which we have taken, so that is the element of what we can say comes under average case. Okay, whereas worst case is the same as the worst case of your bubble sort algorithm, that is of big O of n square. Now this thing will happen if we take the pivot element such that it is either the smallest or largest from the list. So for example, from this the smallest element is 8. So from the actual data, actual array, this was our input array, if we have taken the pivot element something as 8 or 36, in that case, or if we compute the time complexity over here, would have got big O of n square. Okay, so that's it for this session. In the case you have liked the video, kindly hit like and subscribe. Thank you.